I've been doing software for the last 2 decades, but a lot of times it feels like it's software that actually does me. So hopefully this talk will be some amount of fun for you as well. Anyway, so let's get started. Anybody recognize this logo? Actually, that's a trick question. My colleague Dave actually talked about this earlier in one of the presentations, and you throw it around. You definitely know this logo. How about that? Does anybody know what Cyberpunk 2077 is? You know, this is why when it gets hard, you know, you're not in front of a real audience. So I'm visualizing you all saying that you know what this is. Okay, here's one more. How about this angry young man here? Anybody recognize him? And if you do, just put it in chat. Although I'm not going to look at it right now, but and give yourself some brownie points for knowing who this is. All right, here is one more, last one. This book, of course, I mean, this is such a fundamental part of what we do at Thoughtworks, the continuous delivery book written by Jez and Dave Farley. Really formed the basis of a lot of our thinking. Definitely seminal if you haven't caught up with it yet. So, but what's the point? Why are we talking about Tesla, Cyberpunk, Dave? Well, actually, that guy is Dave Farley. He is one of the co-authors of the seminal book, CD. So, if you didn't know, you know him now. And he actually talked about both Tesla and Cyberpunk 2077 on his YouTube channel, actually. And this is Dave in a much better mood, I guess. And he talks about why Tesla can't be caught and why Cyberpunk, a very highly anticipated video game, if you're not into video games, was supposed to be was slated to be the best-selling video game of all time. But instead of that, it came to a point where Sony actually had to pull the game from the store and also offer refunds. And if you look at Tesla, they are just killing it. I mean, not just their stock price, they have a lot of other things that they seem to be doing really well. And Dave talks about this in a lot of detail. If you are interested in knowing more, you can absolutely catch up his YouTube channel. This is not an advertisement for his YouTube channel, but it was definitely an inspiration for me. So definitely catch up on it. So, so what is it that Tesla is doing differently that Cyberpunk 2077 is not, right? And we were, you know, Scott and I, like he said, we were talking about this in the hallway. And what I thought was maybe we should try and catalog, you know, what successful teams do. And we'd like to think that a lot of our Thoughtworks teams fall in that bracket as well. So it's a little bit of self-promotion, but I think you don't mind that. So ultimately, we are all building software. I guess that's me being Captain Obvious. But you've got business ideas on one end, and you've got customers on the other. And in between, you've got two chasms to cross. One is your delivery pipeline, where you build a bunch of software and put it in the hands of your customers. And on the other side, you've got this feedback loop, where you're trying to understand what your customers are doing, what they find valuable, and then use that to adjust and replan what you do next. If, as you can see, this is a continuum, a loop. You know, so if we are to build better, more valuable software, this continuum or this potentially infinite loop has to be optimized. And to optimize this loop, we need three characteristics to be present. We need the software or the thing that you're building to be rapid. we need it to be reliable, and we need it to be repeatable. All three are needed at the same time for this to be sustainable. You take any one of these away and it can fall apart. I guess in the case of Cyberpunk, maybe they didn't have one or more, or maybe none of them, because Cyberpunk actually took several years to build as well. Now, if you look a little bit more closely in terms of what the elite performers are doing, the state of DevOps research championed by Dr. Nicole Forsgren, Jez Humble, the other author of the CD book, and Gene Kim, they release this report every year, the State of DevOps report. They released it this year as well. If you haven't caught up with it, please do that. And they actually talk about these 4 things that seems to differentiate the elite performers from the not so elite ones. And it's about your ability to deploy a lot more frequently, reduce your lead time, your mean time to restore, and the amount of changes that actually fail. And they actually make it pretty easy. You can answer these 4 questions yourself, and they have this quick check application online, and they do this per sector. So if you're healthcare or airline or finance or what have you, they actually rank you in comparison to where your competition might be. So it's really valuable and very quick way to understand where you are. Now, let's say you do understand where you are, but the question really begs you is, how do you get better? And to answer that, let's look at the engineering value stream. The engineering value stream, if you look at it a slightly different way than what we just looked at previously, you're planning something, you're coding it, you're validating it, running some tests, packaging it, deploying it, running some more tests, releasing it, monitoring it, and then this whole thing continues over and over. Now, what we looked at was, okay, what is it that software teams can do, and are there specific things that you can do while doing all of these things to ensure that you remain rapid, reliable, and repeatable? So let's take a look. So I present to you what we call the value stream periodic table. Now, this is something that one of our colleagues said, and I liked it, and I'm like, okay, that's what I'm going to use. Basically, a set of practices and activities that are performed in an intentional way that are with the sole aim of reducing the time that it takes to move through that feedback loop. Now, as you can see, there's a lot here, and there is more. Now, the question is, are we saying that you have to do exactly these things to become rapid, reliable, and repeatable? No. Are we saying that all of these are equally important? No. What we are saying, though, is in our experience, a lot of these do tend to be very important. In your specific ecosystem, some of these may not be as important, some of them may not be even relevant, but we are seeing a lot of success adopting a lot of these things pretty intentionally. So at least that's what our experience tells us. And what we have done here is tried and catalog a lot of these. And if you look a little bit closely, and I apologize, this is a bit of an eyesore, this slide, but if we didn't show it, it would be me just hand waving a lot. So we thought we'll put it in here anyway. So we'll send these slides to you so you can take a look at them in your leisure. But the point is that there is so much, and each of these are epics and topics by themselves. And you've got only 15 minutes, which I'm very close to finishing anyway. So there is a lot. So what do? So you do this thing that all responsible engineers do, which is prioritize. The question is how. So what we've done is we have said, okay, here is a technique that we've used. So you've got two axes, you've got value and you've got current adoption. So if you think something is really high value and low adoption in your environment, maybe that's something to focus on. The other way to do this is to say, you know what, okay, something that is high value and something that is high feasibility as well in your ecosystem, and then go after that. In an ideal world, what will happen is you plot both of these, and then you'll see hopefully the same thing appear on both graphs. And maybe that's the thing that you need to focus on first. Okay, so let's say you're doing all of this. Let's say you're saying we are already doing unit testing. We're already doing software security testing. Both dynamic, static, all of that. But the question is, how do you know that you're actually getting better? You know by measuring, I guess. And yeah, if you can't measure it, I guess you cannot improve it. But then our own chief scientist, again, not in a good mood, I guess, that's Martin Fowler, says that you just cannot measure productivity. And false measures will probably make things even worse. So then what is it then? Are we left with just this then? This, again, apologies for some of the bad language here. So this is a joke, the less WTF, and I'll leave it to you to figure out what WTF is. The less, the better. So really, the question is, are we left with just this as a definitive measure of us making progress? We think there is a slightly better way. And this is, again, us presenting to you the half moon, as Scott actually called it when we were talking about this. Now, basically what we are saying here is it's a folly to look at any single one of these metrics in isolation. So, for example, velocity is very popular. Low velocity means that you're not doing well. Oh, you've got low code coverage, you're not doing well. But then we all know that it's very easy to gain these kinds of metrics. So what we're saying is, don't look at anything in isolation. Look at a set of dimensions. And in this picture, we are showing you 5 dimensions. Again, the dimensions that you use may be different. The actual metrics under each of these dimensions may be different. But the more sources you look at, the better you can derive in terms of insights, in terms of improvement opportunities, and also not to use this as a carrot and stick. So a lot of places it's like, you need 120% code coverage, otherwise you're bad. And now what developers do is they're like, okay, I will, because we are very smart people, we bump up those numbers pretty quickly by writing a bunch of bogus tests. Code coverage looks really, really amazing, but then you're actually not moving forward in any of those 4 key metrics that we talked about. Lead time, not improving. Change failed percentage, not improving. MTTR or release frequency, again, not improving. So don't do that. Look at a bunch. And the last thing I'll say is ratchet. Now, this ratchet is a device that only turns in one direction. And so similar to that, what you do is you set yourself an intermediate small target. You then achieve that small target, and then you set your baseline to that new number. And then you do this continuously over and over. And using the prioritization method, you can now keep making steady progress, or fast if you have the time and the budget to focus on more than one thing. So the question then is, where are you? Are you closer to cyberpunk, or are you closer to Tesla? And I'll leave you with that. Thank you very much. Any questions you might have, more than happy to answer.